how to handle some events, various events in different occasions. We will see with the different examples, right? Next, after understanding that, now today we are going to discuss about angular pipes. Angular pipes. What are pipes and why do we use pipes? Till now, we learned everything about components. In Angular, we discussed about components, how to deal with the components. Actually, pipe is used to transform data. Pipe is used for transforming the data. Actually, data comes to your Angular application, application from various sources. So the data type of source provider. So source provider, and the data types supported in TypeScript. TypeScript usually will not match. TypeScript will not match. So due to that, what happens is the data is not displayed in the same format how we are expecting. So what is the intention of pipe? Pipe can transform the data and display in a desired format. Pipe can transform the data and display in desired format. Sources is provided to our Angular application. So which is using TypeScript for handling and interacting with the data actually. And generally data comes from various sources. Suppose, so the data is in a varchar form. Data is in a date form in database. Some databases will have an integer like. So they have a currency like, they have like number. I'm talking about different databases and their data types. Some databases even have a money type data. Now, when data is present in various formats, that means various types of data is there in the database. And suppose this data need to be displayed in our TypeScript. So then TypeScript supports only one number for displaying all of them. It provides only one number for displaying all of number types. That means For a float, it uses number. For a double, it uses number. For a decimal, it uses number. For a decimal, it uses number. It uses a number type for all of them. So for money, it uses number. For currency, it uses number. For int, it uses number. Due to that, problem is the data that we are expecting in a format to display, it cannot display in the same format. We have to transform the data. I will show you. We need to transform the data. So the data need to be transformed. So pipes are designed to transform the data. Actually, all pipes in Angular are derived from. So pipe transform. They are derived from pipe transform base. Derived from pipe transform base. They are all derived from pipe transform base. And every pipe implements a functionality. So by using transform function, by using transform method actually. By using transform method, what we can do is Angular provides several built-in pipes. Angular provides several built-in pipes, and also allows to create custom pipes. So we can create our own pipes. It allows several built-in pipes, and it allows even to create our custom pipes. We can create our own pipes for every requirement. Whatever we need is not supported, is not available. We have to create our own. So that's very important, right? Technically, so we will discuss about this. We will see an example for that. Actually, what happens is, I will just tell you the option here. We have a pipe transform. Pipe transform is a base. This pipe transform base contains actually a transform method, and it will take your value and it will apply some format on that value. It will apply the format on that value. That means, for example, it is going to return so the value into uppercase. Uppercase is a format. So that means it will return that value in uppercase, and this pipe transform is an uppercase pipe. So pipe transform is an uppercase pipe. So uppercase, it implements pipe transform. When it implements pipe transform, so pipe transform is having a transform function which will take your value and convert into uppercase and return into uppercase. Generally, what happens is we can apply this pipe on our text. So you have your text. To your text, pipe can be applied by using a pipe symbol, and uppercase. Now what happens is, so whatever data is present, so that means this text is passed into this transform function. It will convert that into uppercase, and it will return that into uppercase now. That means without manually writing any functionality, you can just apply a functionality for that. So it will take care about transformation. Because to change the data, to transform the data, we need a lot of function to write. Without writing much functionality, so we can simply transform the data. So that is what actually transformation. the transformation of data. So how we can transform the data. Actually, every pipe works like this in the background. That we will see while working with custom pipes. Pipe name is defined with a pipe name. So which is configured, which is configured using a at-the-net pipe marker. At-the-net pipe marker. Every pipe is defined by using a pipe name, which is defined by using at-the-net pipe marker actually. So that is at-the-net pipe marker. So that is actually the concept at-the-net pipe marker. So technically what happens here is usually every pipe. So every pipe implements the pipe transform base class, and it have a marker, and the marker is pipe. That's the reason. That means I will give you the basic syntax. Like usually a pipe generally looks like this. So we have a export, so export class, and you have an uppercase, and it implements pipe transform. Pipe transform is the base. When it implements the pipe transform base, now it have to import the pipe transform actually. That means it should import the pipe transform. So import, so it should import, so pipe transform. So pipe transform from it has to import from Angular core library, then it can implement. But important is it needs a marker. So it needs a marker. This marker will define a name property for the pipe. And the name for that is, it is having a name, some uppercase. Uppercase is the name for the pipe. So that means, that is the reason sometimes the pipe class name is different and the pipe access name is different. Class name is different and its reference name is different. So because it uses a selector, and pipe usually have a transform method. It will have a transform method which will take your value and it will return that value. It returns some functionality. So return any format. Return. So it return here the value. So the value is returned in any specific format actually. This is the basic approach how the pipes are actually designed in the background. Every pipe is designed in this way. We can create our own pipes also, which we will see. Now this is a reference name for the pipe. That is the reference name for the pipe. So Angular provides several built-in pipes. Angular built-in pipes. That means by default, Angular has some pipes provided for us, which you can use to handle various formats. Angular built-in pipes, we have an async pipe. Async pipe. So we have a currency pipe. So we have a date pipe, we have a decimal pipe, we have a I18 plural pipe. This is new from Angular 8 version onwards. And we have I18 select pipe, that is also new. We have JSON pipe, and we have key value pipe, it is also new. And we have lowercase pipe. We have uppercase pipe. We have title case pipe also new. And we have percent pipe, and we have slice pipe. These are all the built-in pipes. Angular provides all these built-in pipes. So these pipes are predefined with certain functionalities. We can use all these pipes for different types of functionalities, usually. So these are all built-in pipes. Now you can apply the pipes. Actually, Angular pipes are assigned to your data by using a pipe symbol. And very important is, actually, Angular pipes, they will not change the value. They just define a format for the value. They will not change the value. They will just define a format for the value. Then that is the reason generally Angular pipes are by default pure pipes. They are by default pure pipes. They are by default pure pipes. So that means they will not change the value. Technically, they will not change the value. They just define a format for value. So that means the point is only the format is changed. Value is not changed. Value is never affected. Only the format is changed. So actually, if pipe can change the state, and value, then it is impure pipe. Then it is impure pipe actually. Then it is impure pipe. That is what actually you should know about pipe points. I will show you both of them. That means technically using a pipe will not change the form, will not change the value. They will just apply a format for the value. They are not going to change your value. That means if it is 400, it is 400 only. They will apply a format for the value. So that is what actually we call as impure. Pure. Impure means they can change the value. That means during the course of application at different states, it can return different value. At different state, it can return different value. That is impure actually. If it is going to display the same, then it's not an impure pipe. Actually, this is the nature of the pipe. Now our developers, right? Our developers invent new concepts and they classify pipes into pure pipes, impure pipes. Two pipes are there. Because I know that immediately after the session, many people who don't have a proper knowledge on this, they will ask, sir, there are two categories of pipes, pure pipes, impure pipes. What is difference between them? Angular never released any pure and impure pipes, but we don't know from where these people has invented a new concept. They create some new topics for us and they categorize. Due to that, many people are misguided, right? Now, they start with a classification. Pipes are two types, impure pipes, pure pipes. That's not correct. Why? Because the point is a pipe defined, that is a pipe defined. So usually, yeah, usually the pipe defined is by default pure. A pure pipe can be replaced with an impure pipe also, transformation. Dynamically, we can manage that also. So that is the reason. So you should not classify the pipes into pure and impure, right? So you need to know that if at any particular situation it is changing the value, then it have an impure behavior. Pure and impure are the behaviors for the pipes, not the categorization of the pipes, right? So because many people will come with this question, because several websites or somebody somewhere else have shown a classification of pipes. They say that pure pipes are there, impure pipes are there, two different categories are there. So due to that, confusion will come, but officially Angular never classifies the pipes. All the pipes are one. Only as per their behavior for the situation and the state, we recognize that, okay, it have a pure behavior, it have an impure behavior. That's it. Right. So how do we use these pipes and how do we work with the pipes? We will see that. That means usually how the pipes are applied syntactically, how the pipes are applied. That means you need to configure your data and a pipe symbol and the pipe name. You have to define the pipe name. So you can configure the pipe. You can concatenate multiple pipes, and the pipes usually can have, you have options. Pipe options are defined with a colon. With a colon, pipe can be defined with options. That is what actually the pipe options are. Right. So that is generally all the pipes. We will see how to use them. This is the list of all the pipes currently available up to Angular 10. Up to Angular 10, these are all the pipes available, right? And some new pipes are added in the new Angular 8 and 9 versions, so which are all included here now, right? So we are going to deal with all of them. It is not an order, just I given a list of all the pipes available. Now we will see how to use these pipes. How do we work with the pipes? Let's see. How do we deal and work with the pipes? I will go into our application. So let's create a simple component here. Let's add one small component. Yeah. ng generate component pipe demo. Okay, skip this. Okay, I'm just creating a new component here. And let's keep it in the startup. So pipe demo. Okay, pipe demo. And let's define this in the startup pipe demo. Pipe demo component. Okay. Now, yeah, we defined this. Now here, so let's compile and run this. Already it is there, fine. Let's add some data into that and we see why we need the transformations, why we need the transformation. Okay, so pipe demo is working. Yeah, so let's go to the pipe demo and keep some content here. So here just I'm displaying some data. So let's keep this with some data. So public product is having a name, so some name, and we have price and price. Okay, so now we have MFD, that is manufactured. So you know how to store the date values, and it is a string 2020 and 0, 3 and 20, something like this. Okay, so these are few details we are having, and let's display that in the HTML page. So when we are displaying in the HTML page, now you can observe that the data that we are expecting container. Okay, and here I am displaying the data, product details, and here, so data list, data term, name, and data definition. So here we defined as product dot name, and here data term, so price, and data definition we have product dot price, and we have MFD, manufactured, and we defined manufactured, product dot MFD. Okay, so these are all the details we are having. MFD in the component, it is MFD, yeah, manufactured, yeah, fine. Now you can see that, so you can observe here, now you have some problems in the data displaying. You can examine that. So you see my number value is 50, but it is not displaying the leading zeros. Okay, and I displayed date in this way, but it is returning the date in this format. You have date functions, 2 long date string, 2 short date string, 2 time string. Date functions, I told you while learning with the TypeScript, we can apply them, right? But how you can transform this data to display in your convenient way? For that, we can use the pipes. That means data is not displayed exactly how we are expecting it. That is the problem with the data. So in that case, now let's see how we can use these pipes and work with the pipes. So how do we deal with the pipes and work with the pipes? So I will just create a table to explain these pipes and description. Yeah, so here we have an pipe name, pipe and the description. Okay, and we have the pipes. So we have a pipe, uppercase pipe, and uppercase pipe. So usually this uppercase pipe, I will add another column to right here. Okay, now here we have the pipe description. Okay, actually this is a name. So the pipe and its name and its description. Okay, its name is actually uppercase. Its name is uppercase, and its description, you know, it is nothing but it converts all letters into block letters, that means into uppercase letters. It converts all letters into block letters, so uppercase. And we have a lowercase pipe, and usually its name is lowercase, and it converts all letters into lowercase letters. And we have a title case pipe, so that is title case pipe. In early versions we don't have, recently advanced versions we have this title case pipe. So title case, that is actually title case pipe, and it capitalizes the first letter first letter of every word, every word. It capitalizes the first letter of every word. So it sets capitalization for first character. So first character, right? First letter of every word will be capitalized. It sets capitalization actually. So that is what actually title case. These are general things. No need to explain much about them. Suppose I want this name. It is printed. I want this name. So this is our data. And I want this name and I'm adding uppercase. And you can see that this uppercase, pipe uppercase, go to definition of this. It is actually uppercase pipe, which is implementing pipe transform. That is the class name from where it is derived actually. And it is using a transform function. It is using a transform function. So technically it is using a transform function to transform the data. So this is uppercase pipe. Every pipe is derived from this. And important is every pipe usually have a marker because this is the complete library imported at one place. So, and important, you can see these are all the pipes. So these are all the pipes and these are all the options for designing the pipes and their functionality actually. This is the library for designing the pipes and defining functionality for the pipes. We can create our own pipes also, which we will see later. Initially, so the class is uppercase, but if you use this and you can see it is converted into uppercase letters. All are converted into uppercase letters. Now, if similarly we can use lowercase, it converts into lowercase letters. So I'm defining lowercase, it converts into lowercase letters. All are converted into lowercase letters. It changes to the lowercase letters. Title case, every word first letter will be title. So every word first letter will be capital. Title case, it keeps every word first letter capital. S and T will be capital here. So generally, that is how we can configure the case. We can define the case for our text. A simple example for this is, suppose we have this data defined. We have the data defined here. Just here itself, I will give an example. We are defining the data here, just the data here, and we are presenting the data for the text, and we are presenting in this way. So this is the presentation where we are applying that pipe. Right. So the product name is displayed in uppercase. It converts that into uppercase and display. So that is, this is an example for all of this, right? So similarly, you write for, this is for uppercase. So this is for lowercase. So you have lowercase, and we have for title case. So title case. That is actually the same thing. So we are defining for all of them. That is how we can change the capitalization actually, capitalization of the text. Okay. Next important, another pipe, we have a decimal pipe. But interesting part here is decimal pipe is used by using a selector called number. It is not decimal, it is number. Pipe name is decimal pipe, but it is accessed by using number. Number is the name actually. So what is the purpose of this? Actually, it is used to display numeric value with thousands separator, and it is used to display with thousands separator and fractions. So fractions and fractions. So technically, it comprises of syntactically, it comprises of minimum integer digits, minimum integer digits. Several things it comprises of. I will give them. Yeah, it comprises of minimum integer digits. It comprises of minimum minimum fraction digits, and it comprises of maximum fraction digits. So minimum fraction digits, and it contains maximum fraction digits. So maximum fraction digits actually. What are those? I will tell you. Usually decimal pipe comprises of these things. Technically, it comprises of these things. So it comprises of minimum integer digits, maximum integer digits, and so maximum fraction digits and minimum fraction digits actually. So syntactically, how we generally apply this, usually how we syntactically apply this. So we have any data and a pipe number, and this is provided with options. This is one way. We can define with options, generally data, pipe, number, and you can define options. Usually options comprises of minimum integer digits, minimum integer digits, and it contains dot minimum, so minimum fraction digits, and it contains a hyphen, and maximum fraction digits, fraction digits. It comprises of this. That is the basic syntax, how generally we define for the options. That's how we define the syntax. So this is the general syntax for defining that. This is the general syntax. Yeah, this is the general syntax. Right. Technically, it have minimum integer digits, dot minimum fraction digits, and maximum fraction digits. Okay, I will show you that. Means how it actually handles that information. Technically, just for syntactical purpose, right? I'm giving example. We will see, means how it is configured and used. So suppose this price is generally displayed like this, and I will put here a pipe, and the pipe is actually, we have a pipe called number pipe. We have a number pipe. When we apply this number pipe, actually observe, go to definition. This number is actually a decimal pipe actually. Decimal pipe. But its reference name is number. So we have to access by using number. And you can see that immediately it will apply a number style. You see 1,000 separator came. 1,000 separator came. Comma is there. But fractions and decimal places are not there. That means we are configuring in this way. So that means we are defining in this way. So suppose we are configuring the values. So values, so many are there. Example, I will show you different scenarios. So we have some price. So price is defined with some value 450050. And we are applying the pipe here. So price directly we are defining here, price. When we are directly defining the price here, and you can see that when you configure the price directly here, it is going to display 4500 0.5. That's it. It is going to display only that. Now I'm applying some pipe here. So price, and I'm applying a number pipe here, number pipe. And when I apply that number pipe for that, so you can see that when we apply a number pipe, you can see the value it will display by using 45,00.5 like this. But still the fractions and decimal places are not satisfying. 1000 separator comes there. Then how do we define here? See, I'm writing here colon. I'm defining options. So you have to define in a string. Here we have to first define the first value is minimum integer digits. Minimum integer digits means, so before the fraction, how many digits you want? Before the decimal place, how many digits you want? So how many digits? So I want 5. Remember, if you change it to 4 or 3 or 2 or 1, so it is not going to remove one number, right? It is mentioning about maximum number of integer digits. Maximum number of integer digits, how much you want to specify. Reducing that will not affect anything, until or unless it is having some leading zeros, right? So I said 5, okay, dot, I will show you that, right? That means we are defining the minimum integer digits, right? So here we are configuring this. So in this, the first point is minimum fraction digits how many and maximum how many. Minimum fraction digits 2. Maximum also 2. That's how we define. Minimum 2, maximum 2. So minimum 2 fractions we want, maximum also 2 fractions only I want. Because later if something more fractions are passed, it should not show them. You can see that. You can see it is now 50. Suppose the maximum I will allow 3. Then you can see it will show that 3 fractions are there here. You can see 500. So this is 50. Even if I define 3 or 4, it is not showing any 4 fractions because already in the value there are only 3. Only 2. In the value there are only 2. Maximum you are saying that 4. So minimum how many you want? So minimum I want 4 or minimum I want 3. That means you can see that now the minimum fractions will be applied to that. Minimum fractions will be applied to that. So that means it is applying the minimum fraction to that 5000. So, but important 4, this indicates that maximum fractions how many. So that means the minimum and maximum fractions how many. That's how we have to define. So later when you are passing the values, so it will make sure that it is within that specific range. Change this to 2 integer digits. It is not going to shrink your value actually. It is not going to shrink your value. It's not shrinking your value. But this is actually to mention that how much maximum range of value is good for this number. Integer value is good for this number. Because due to this, based on this value, we can later set a validation for that value they are enter into it. We can set a validation. Currently, I am defining, you can bring from any dynamic location. You can create a variable in that you can put these values and use those variable names here so that it will use only those values coming from there. Technically, another example I will show you. Initially, we are just understanding how the denotation happens actually. So maximum integer digits 5 and minimum integer digits this. Right. For example, suppose it is starting with 0. It is starting with 0. That is an invalid option because 0 it is an octal literal and it is not allowed with an octal literal. It is not in a correct octal format. Right, the leading spaces, so they will in the fractions, they will be taken care. It will display exactly, right? Only the fractions which are not displayed, for those we are using these transformations. You are using these transformations. So technically, so for number, we have this option to define. So that means minimum digits, maximum digits, and how we can configure. So this is one simple example. That means here we are defining price, and we have a number, and we have in the code, so it is 5, so hyphen 4 hyphen 5 dot, so here we have 4 hyphen 4. This is going to display, so 4500 point, so 5000. That's what it is going to add. Suppose it says price and it is a number and it is using 5, and here we are defining as some 2 value configured as 4, so suppose 2 and maximum 4, like this we define. And in this case it is going to use, yeah, in this case it is going to define, yeah, so in this case it is going to define, so 45,00.50. That's how it is going to display the values. This is a basic example here to understand how the numbers are transformed. So how the numbers are transformed and how the numbers are displayed. This is transforming of number. There is another option, so currency. So currency pipe. Currency pipe is same as number pipe. This is done with currency, same as number pipe, only that it will provide currency symbols and currency formats. It is going to display the value in a currency symbol and currency format. So that means technically it is used to display the numbers, display numbers in a currency format. So it comprises of 1000 separator. It comprises of 1000 separator. It comprises of fractions and a currency symbol and a currency symbol. And how you can define this currency pipe? The same. What you can do is, for this price, instead of number, I am defining currency. And you can see that it is defined. It is defined with a currency symbol. You can see it comes with a currency symbol. So the fractions and everything you can change as number type. The other options will be as number type. That means we are defining 5 dot, so minimum 4, maximum 4. So, and very important is here one problem will come. The order dependency issues will come. Order dependency issues means actually currency is expecting a currency format first, then digits information. It is expecting a currency format and digits information. That means the basic syntax of currency, usually it is expecting, so your data with a currency, and here first we have to define, so currency format, and then we have to define digits information. So we have to define digits information. Now if I do like this is wrong representation actually, then you can see it is not displayed in a correct way. So why? Because first I need to configure the currency format, and here we have predefined currency formats. So different currency formats, so many currency symbols are available. You can apply a currency format. You can also use currency literals. Actually, currency format means what? So currency format. Usually currency format means you can define the currency format as USD, INR, like that. You can define the currency formats like this, or you can use literals for currency. Currency symbols quotes will be there. You can use those currency literals that are generally HTML symbols. And digits info is nothing but digits info is same. What is the digits info? Digits info contains min integer. It contains min integer, and it contains dot min fraction, fraction, and hyphen. It contains max fraction. So this digits info is same like as you have defined for that, right? So we have minimum integer, we have minimum fraction and maximum fraction. That is the basic syntax actually. Only the currency format is important here. That means I defined currency format INR. Then it will get that currency symbol and display the currency symbol with the decimal places here. And you can see that will come. And I said suppose USD. So these are all the currency symbols you can configure in this way. Actually, so we can use a symbol. I can use INR, it will get that. And I can use some literals also. So different literals for different. HTML provides some literals for presentation. We can use different literals. So for example, this is an example here. We are defining the price in this way. We can use literals. Literals means, so here we can see, suppose I said, I'm using just RS as a literal. And if I say RS as a literal, then you can see that here it will get that RS as a literal, general literal. And here I can change this to, so ampersand hash 8377. So that is for euro. So that means that is for Indian rupees. That means it will get you an Indian rupee. Usually, generally, several literals will be there. So here we have euro. So euro, something like euro. So these are basic literals. So we can see euro symbol will come. Different types of literals will be there. You can use those literals. These are all HTML literals usually we can use for displaying. So that means I can use ampersand hash 8377, that is for Indian currency symbol. That means it will get us the Indian currency symbol and display there. So that is for displaying the currencies, how we can manage with the currency. So this is an example for currency pipe. So how we can configure the currency pipes. So same like number, only one point is that it will have a currency symbol, right? Now, another important now is how we can deal with date pipes, how we can manage date, asynchronous, and other new pipes that are introduced. That we'll see in tomorrow's session, right? Tomorrow we will finish pipes concept. Then we will go into, we will see custom pipes, how we'll create our own pipes also. Mostly by tomorrow, if we can finish pipes, then we can go into services and you can learn about services in the next session, right? Tomorrow, we will continue with that, right? Why you are in a hurry? You will learn about all the pipes. I told we have so many pipes to learn, right? So you will learn, yeah, right.